Stan Gibilisco here, proprietor and operator of amateur radio station W1GV, Whiskey 1, Good, Vibrations, with an idea that I've never heard of before. You've probably heard of diversity reception, in which two antennas, call them antenna X and antenna Y, on the same frequency, tuned to the same resonant frequency, are fed with equal lengths of feed line to a splitter transmission line, probably open wire line to minimize losses and minimize SWR worries, to a splitter. That means you just connect them together basically, and with a characteristic impedance of half that of these other lines, ideally, you run this line to the radio. There are many ways to do this, to accomplish diversity reception, but the objective is basically the same in every case, and that is to separate the two antennas by a distance d, usually several wavelengths, so that signals from a distance, from the same originating station, will arrive with different fading characteristics because of the different locations of the antennas. That's common in shortwave radio communications, that is, high frequency or 3 to 30 megahertz thereabouts. If you do this with reception, you reduce the amount of fading that you get in your receiver. I wonder if the reverse could perhaps hold true, that if you had a transmitter here instead and sent two signals out over antennas separated by several wavelengths, in phase with each other but quite a ways apart, that the resulting signals at distant points would always average out the fading characteristics in such a way that everyone would hear your signal fade less because of ionospheric propagation characteristics than they would if you used only one antenna. I wonder if anyone who's watching this video has ever heard of this done and what the results were. So I'm going to try and remember to leave comments open. Stan Gibilisco, W1GV, saying 73 for now, and so long, which in my native fist translates to da-da-da-da-da-da.